Hello, today's lesson will be on measuring volume. Measuring volume. Sometimes it's called capacity, okay? And we're going to start capacity. We're going of 3D shapes, of 3D shapes. I hope you know that the letter D in 3D or 2D stands for dimensional, three-dimensional shapes. Now, which dimensions are we talking about? So let's consider this cube, right? The edges of the cube are of equal length. What are edges? The edges are right here. 1 edge, 2 edge, 3 edge, 4 edge. As you can see, I'm tracing the edges. Now, the edges is the space where two faces meet. So we have this front face and we have this side face called lateral, and the edge is the place where two faces meet. And this is face, just like a face you have. Now, these spots are called, this is vertex. And when we talk about plural, like vertex, 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 and other vertex, they're called vertices, vertices, or CES. Vertex is the spot where three faces meet. Three faces meet. So let's draw another one. This is our top face. So we have a front face that's yellow, we have a lateral face that's pink, and we have a top face that's red. And this is the vertex where three faces meet. Now, this is a cube, right? Because all the sides of each face are equal length. Every side of each face is of equal length. Now here, the front face, as you can see, is a rectangle. We call this rectangular prism. Rectangular prism. Rectangular prisms are 3D shapes where faces are rectangles. By the way, there's 6. How is a cuboid different? Well, cube, every face is a square, and cuboid, where every face is a rectangle. Some can be squares. Like, for example, this face will be a square. I say it's like a stick of butter. That's your perfect rectangular prism. Let's delete this. Okay, so how can we draw a cube in multiple ways? Well, I usually teach my students this way. This is front face. Somewhere here, you will leave some space and you make the back face, and then you fill in the edges, right? These are the visible ones, and this is invisible. So this is how I draw a rectangular prism. You can also draw it facing this face, right? This way, you can kind of go like this, but I'm not really good at it at all. And then you would connect it. So you have something like that, okay? This is how we draw it. But my favorite way is you do the front, you throw some in the back, and you collect with the edges. So let's count. We are talking about volume, the space, the three-dimensional space an object occupies. So here's how I typically teach to count. We have 4 cubes in the front. You see, we have 1 row, and behind it we have another row. So this is 4 taken 2 times equals 8 cubic units. Here we have front 4 and the same on the back. So it's 4 taken 2 times equals 8 as well. See, same volume, but looks very different. And here we have 1, 2, 3, and this 4, right? So it's like this L shape, right? So we have 4, but we have 2 layers, right? Times 2, also 8. How interesting. And here we have kind of like a T shape, right? Like letter T upside down. 1, 2, 3, 4, 5. 1, 2, 3. And that's also 8 cubic units. We measure volume in cubic units. You see, these tiny cubes. Remember, we measured area was measured in squares, right? We measured area in squares and volume in square units, square inches, square centimeters, square miles, and volume is measured in cubic units. Now, if this is one cubic unit, so all of the above examples, 1, 2, 3, 4, are all 8 cubic units each. Now let's take a look at a precise units of measurement. We are talking about 1 centimeter, which means the bottom edge is 1 centimeter, this edge is 1 centimeter, and the height of the cube is 1 centimeter, which means this is simply a 1 cubic centimeter cube, or we can say 1 centimeter cubed. You see, 3 stands for 3 dimensions. We have length, we have width, and we're adding height for the third dimension, right? It's a 3D unit, 3D spatial object has height. So let's take a look at this. We have a length, we have width, and it's probably better to use a different color, and we also have a height. And this particular cube measures 1 inch, 1 inch, 1. All the edges are 1. So this is 1 cubic inch, or we write it 1 inch cubed. Remember, area was measured in squares. We would say 1 centimeter squared because these are little squares that take up space. And here we're adding height. So they're little cubes, right, that fill up our space. So we're talking about 1 cubic centimeters or 1 cubic inch. Okay, so let's start measuring. Oh, this exercise I really like. We have this, and we are on page 64. We have A, B, C, D shapes. So let's take a look. What's the best way to count them? I like to count them in organized fashion. So I would say this is the first layer. This is the second layer. This is the third layer. And finally, we have layer 4. So layer 4, we can layer 3, layer 2, and layer 1. Let's count. How many cubes are in the first layer? 1, 2, 3, 4. That's 4 in length, right? We have 4. 1, 2, 3, 4. 4 in width. 4 by 4 is 16. Now, next layer. 1, 2, 3. That's 3. 1, 2, 3, 4. 3 by 4 is 12. Next layer. 1, 2. Okay? And then how many rows we have? 1, 2, 3, 4. So that's 2 by 4. That's 8. And finally, at the very top, we have 1, 2, 3, 4. 4. So let's add up all these layers. To sum it up, we have 20 and we have another 20. So that is 40 cubic units. 40, right? 16 plus 12 plus 8 plus 4. Now let's take a look at B, shape B. 1, 2, 3. 1, 2, 3. 1, 2, 3. So the front face, right? The front face of this cube is 3 by 3, which is 9. Now, how many layers do we have? Well, this is our first layer. Behind it, another layer, and a third layer, and finally, I see fourth layer. All together, we have 4. So 9 taken 4 times, 9 taken 4 times becomes 36 units, right? This was 16. Now let's look at shape C. Let's count the front face. We have 1, 2, 3, 4. Good, that's 4 by 1, 2, 3, 4. Yes, it's a 4 by 4 square. So we have 4 by 4 equals 16 units. Now, how many rows do we have? Well, that's the first layer plate. That's the next second plate. That's the third plate. And behind it, there's a fourth plate. So we have 4 rows. 16 times 4 equals 64 square units. Finally, look at this D shape. It's quite interesting. Again, we have to stay organized. So let's first consider the front part. Okay, so we have 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 by 2, so we have 2. We have 5, so 5 by 2. The front face has 10. But we have front, and then we have another one on the back. So we can say 10 times 2, that's 20 in orange ones. Let's do next one in purple, right? We can say 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. And then see behind it is another 5. So that is 5 by 4. Let's write it down. 5 by 4, right? It's a little bit taller, equals 20. And we have two of those plates, 20 and another 20. So 20 times 2 equals 40. So together we have 60 square units. So this is how we count it. Always stay organized. Don't try to count everything. Split your 3D shape into simpler components. So volume of rectangular prisms. Let's take a look. So the rectangular prism, this particular rectangular prism, is made up of these cubes, right? They're 1 centimeter cubes, meaning we have the front, we have the back, and it's joined like that. So that's 1 centimeter cubes. Well, how many? Let's count. 1, 2, 3, 4. 1, 2, 3. So it's a 3 by 4. That's your front plate. 3 by 4 equals 12. And we have two layers. We have first plate and we have one on the back. So 12 times 2 equals 24. Okay? You can look at it from two different points of view. So the length is 4. The width is 2, right? That's your width. That's your W. This is length equals 4, width equals 2, and this is your height, right? This is your height. This is your height of your 3D shape. So altogether we have 4 by 2 taken 3 times, or we can say the other way, we can say 3 by 4, right? Like we did taken twice. Whichever way you look at it, you will have 24 cubic centimeters. Friends, units are very important. Units are very important. Now, we can look at it like this, right? Let's say we have no lines of separate cubes. Length equals 4, width equals 2, and height equals 3. So, what do we essentially do? First, length times width, that is your area. We're familiar with that. We first calculate the area of a plate, and then we take it as many times as our height allows us, right? So that's your third dimension. Length and width, those are 2 dimensions, and the third dimension is height. So the volume is length times width times height. Let me put it up, times this height, okay? But we can also say it's area, right? The area of this front face, right? Taken 3 centimeters. How would we think about it? Well, we would say 4 times 2, that's your 8, right? That's your 8 centimeters squared, right? That's your 4, and that's your 2. But then it's going this many infinite number of times, 8, 8, 8, 8. How many times? 3 centimeters. So it becomes 24 centimeters cubed, which is the example we looked at above. Let's start practicing. What if we turn the prism upside down? Nothing changes. You just change your point of view, but the volume didn't change. Let's practice. Find the volume. Find the volume. We have a rectangular prism. Length equals 5. That's given. Width equals 2. And height equals 3. Therefore, 5 times 2, always do it the best way for you. The easiest calculation becomes 3 centimeters cubed. Now, let's take a look here. We have length that's given to be 8, we have width that's given to be 5, and we have height that is 6. So let's compute 8 times 5, that is 40. That's the area of, don't run away, of the top face, or you can say the bottom face, right? Somewhere here, there is the bottom face like this. Right? So that's 40 centimeters squared. And then we have to take it 6 times, becomes 240 centimeters cubed. Remember, 3 dimensions cubed. Now, let's do this. What is given in this prism, in the pink prism? On the right, we have length that's equals 8. We have width that's equals 4. And we have height that's equals 5. So let's do volume. Volume equals 8 times 4 times 5. My friends, always try to compute the easiest math, using the easiest math that gives you fewer mistakes. We know that 4 times 5 is 20, and 8 times 20, 160 centimeters cubed. Always put your answer for your teacher in a circle. Let's move on. Find the volume of each cube. Well, what does it tell us if a shape is a 3D shape named cube? It means all sides are equal. Every face is a square. So we have 5. This is also equal, right? It's 5. And the height is also 5. My friends, the volume equals 5 times 5 times 5. I hope you recognize that it's 5 cubed, which is the same as this is 25 times another 5 equals 125. That is still not a complete answer. 125 centimeters cubed. I hope you are getting a hang of it. Now we have a cube that is 8 by 8 by 8, right? Every face is 8, length 8. So length is 8, width equals to 8, and height equals to 8. Therefore, the volume, we always write it like that, V for volume, equals 8 times 8 times 8. We also know it to be 8 cubed, and I will let you figure that volume. I will let you figure it out. Now, the most important thing that we're going to leave our lesson in is that in mathematics, which comes from physics, which comes from the definition in the real world, we usually say that a 1 liter of water, 1 liter of water, we already know that it's equal to 1,000 milliliters. That we know from last unit. But today we're learning something different. If we have a cube that has length of 10, width of 10, and a height of 10, if we fill such a cube with water all the way to the top, it will contain 1 liter of water. My friends, this is a very important universal standard, metric standard of measurement, that when we have a cube that is 10 by 10 by 10 centimeters, which is 1,000 centimeters cubed, it fills with 1 liter of water. I write H2O, that's the chemical formula. So, very important, some piece of information we're going to keep using for the rest of today's lesson. 1 liter is 1,000 milliliters and 1,000 cubic centimeters, which means that one tiny milliliter, one droplet of water, is the same as 1 centimeter squared, cubed. So this is important to remember. 1 liter is 1,000 cubic centimeters. 1 liter is 1,000 milliliters and 1,000 cubic centimeters. I hope you find this useful. We will resume on page 68.